Thank you. Soham, feel free to start whenever you want.
Yeah. Hello and welcome. I must say I feel a little bit overwhelmed by the size of this, because so far I have presented 50 to 60 people, but this is huge. This is huge. I think it's a bucket list for me, definitely. So today I'm going to talk about RAG, but I'm going to talk about RAG in a context of one of my favorite movies, Ratatouille. So how many of you know what RAG is? Quite a few people. How many of you have implemented a RAG? More or less people. OK, my presentation starts with the basics of it to give you the understanding of what RAG is and what are the different components within a RAG is. Also go into a bit of a details of nuances, because everybody talks about how easy to set up a RAG application. So if you just search for it in your favorite browser, you'll find, I think, 200 tutorials for AWS, Google, Azure, or any other services to build a RAG system. But nobody talks about how do you build such a system in a production-ready environment. There are a lot of nuances people don't talk about, and I think that's bad. And that brings a little bit of introduction to me. My name is Soham. I work as a solution architect in Microsoft, and I specifically work with startups and scale-ups. We call them ISVs in Netherlands. And my focus area is when a cloud-native application brings GenAI into their platform. And we always start with the discussion of how you're going to do it, what are your documents, what are your data you're going to do it. And that is a long, painful process. And like Neil mentioned, there are a lot of trade-offs you need to consider on, and pick and choose which trade-offs are OK for you and which are not. What's in agenda today? We're going to talk about food without spices. I hate it because my background is in India. I cannot eat food without spices, and how that relates to RAG. We're going to talk about prep work, chopping and assembling. That's quite important when you're building a RAG system. And why? I'll tell you that as well. I think that's the lengthiest part of my talk. I'm going to talk about how you follow a recipe. I am from a software development, design, and architecture background. I like automating things, even though I do it for once. So I'm going to talk about a little bit, when you think about a RAG system, what would your pipeline would look like? And how would you make sure that pipeline automates some of the stuffs in your RAG system? I'm going to talk about Anton's approval. Remember Anton from Ratatouille, the critic? So how would you get an evaluation system for a RAG? When we build software, we write tests, unit, integration, pen test, et cetera, Same goes for a RAG application. Same goes for any GenAI application. And how would you think of creating an evaluation system, a testing system for a RAG? And what are the components are there? I'm going to talk about a little bit of mastering your masterpiece. So what do you need extra on top of your RAG system to make sure the RAG system performs well, or searches well, or gives your data back well? And last two sections are more about a few advanced patterns on RAG. I'm not going to go in detail, but give you the idea of what you can think of when you're building a RAG system. So it's not only a few clicks, but there are architecture decisions and patterns related to the things that you want to build on the RAG system. And I'm going to give you a few use cases on what should you cook tonight. So basically, if you have a use case, how would you make sure to do that? Build that. So food without proper spices. I cannot eat food without proper spices. So for example, if you have a system which gives you back flight cancellation change policies, and you ask to any LLM, doesn't matter which one it is, it'll give you a very blah, blah answer. And that's we call hallucination, fabrication, how may you call it? Because it doesn't know the particular airline or your ticket information to give you that specific answer back. If you are business class, you will have no change things. If you have a ticket which is within 4 hours of travel, you might not be able to change it. So these are information which are missing when you are asking a question or giving a task to LLM. Before I go ahead, I'll tell you, I believe chatbot is the lamest use case for GenAI. There are a lot of good use cases of GenAI to automate backend processes. But just as any Hello World application, to explain it better, I picked up the chatbot. That doesn't mean the chatbot is the only thing. Anyway, but why does it do that? The T in GPT stands for transformers. So all of these models are a transformer generation model. So it'll give you what is the next best thing that it is trained on. So could be, I don't know whether you follow this person in YouTube, 3 Blue, 1 Brown. So this person explains very complex mathematical and architectural things in a very easy way. So he also has a series on how transformer models perform. So I definitely ask you to check it out if you have time, traveling on a train or a bus. But yeah, it gives you the next best possible thing because it doesn't know everything about your data. And your data can be a structural data, can be an unstructural data. It's your responsibility to put that thing in. So looking back at the same example, if we just assign a vectorized knowledge base along with a structured database, doesn't matter which LLM it used, you can still get a better answer back. And now, this system has information about you as a user, what is your ticket, where you're traveling, and also the policies this airline has. And that is the simplest RAG you can think of. So RAG consists of 2 different aspects. The top part, we call it document or knowledge ingestion, and the bottom part, where you basically retrieve that knowledge and use it in a context. Remember the word context. I'm going to come back to this context quite a while back. So the top part is basically an async pipeline. You have a document store or a knowledge base or a structured data which you ingest somehow. Doesn't matter vectorized or not. People tend to think that RAG is always connected to vector. Yes, it is, but you can also have non-vectorized data. Like the previous example I showed you, I was querying a structured database without any vector queries. So yeah, so the top part is the async part, where you ingest your data, put it in a knowledge base, in this case a vector database, and the bottom part is basically when you perform query on that system. First of all, if it is vectorized data, you need to vectorize your query before you query it, and then use that query results as a context to perform the task. So in this case, finding the change policy, or changing a booking, or finding which legal document complies to this case, etc., etc., etc. So now that you know the simplest RAG process, let me talk about why chopping and assembling is an important part. Now, going back to the previous image, the most crucial part of a RAG system is the top async pipeline. If you do that right, the rest of your system will work properly. And that's what I'm going to talk about, why chopping and assembling is important. Because, you know, every food requires a different way of chopping your vegetables or meat or whatever you use. So a salad will have a different size of cabbage than your sandwich. You cannot use, you can, but it'll be a little bit different. So I cook a lot of Italian and Indian mix. So every food that I cook, I have a different way of chopping garlic and onions. And unconsciously, you do that as well for every cooking you do, if you are. So why is that a topic? So for example, I have a small policy document which has a paragraph on how you book your flight, paragraph on how you change your bookings, paragraph on how you cancel your bookings. So if you ask the same question, like how do I change my booking, I can put this whole thing in the context and generate an answer. It can be also about canceling. It can be also about getting your booking details. But think about, this is a small, I think, 10, 15 lines of text. How about terabytes, petabytes of data? How would you put that in the context? It's not possible, actually. If you put all of that text in a context, some LLMs allow you to put a whole transcript of the Wikipedia, but that will also increase your latency. The time to respond will increase. The cost will increase. So there comes a small advantage of doing a little bit of separating the data. So let's say I separated the data into 3 blocks, just picked up a random paragraph length, and now, if I ask the same question, my context is smaller. What you achieved is a smaller, higher performance and a smaller token size. So smaller amount of data transferred to the LLM to reason on. I always compare this with my son, 4.5-year-old. So if I give him a lot of information, he will fail to do the task. And if you specifically give him an instruction, it might happen that he performs this task. So LLMs are also like that. If you minimize the context, be specific about the information that you give, it'll perform and reason better on top of it. But if you look closely, I actually missed a small... Is it that way? Not that way. Cannot find it. But if you look at that, the last line of the first paragraph also have some information on changing flight information. And I missed that. So if I ask the same question, I might miss that information when I gave it. There comes another technique on chunking, is overlapping. So when you create smaller pieces of your data, you also need to have some sort of overlap on your data as well, not to miss information. And right now, if I ask the same question, my context is a little bigger, but I do have all the information. So in chopping and assembling, there are 2 very important things on RAG pipeline. One is chunking, how you separate the data, and how you overlap the separated data. And there is no silver bullet to it, to be honest. And this is one of the process that we do along with the ISVs that I work with for at least a month to figure out how is your document or data residing in your application, how are they connected, what are the perfect size of the chunking and overlap should we do. And it gives me back the old memories of Sunday afternoon tuning the FM radio to left and right to figure out which channel to catch, changing the antenna a bit to figure out where should I place to find it out. So there is no silver bullet to it. You need to perform some actions on subset of your data to figure out how things work. So that's chunking for you. And chunking is important because you cannot send everything to LLM. Minimize the context is better in reasoning. But there are other 4 pillars when you are choosing an LLM for a RAG system are tokens per minute, maximum token the LLM can read, the latency towards it, and the cost. And if you choose one, another one will grow. So it's basically kind of a graph diagram which you have to make sure the trade-offs are properly taken into account. There are a lot of frameworks and libraries available to help you to do that, and some of them are in Llama Index and LangChain. I come from a Java world, so in Java, there are not a lot of chunking process available, but if you're a Python or a .NET developer, you are in luck. There are a lot of applications or libraries to help you chunk your data, and you can test it easily. So you don't need to do it manually. You put a subset of your data through any of this chunker and do an evaluation and see how it performs. But I'm going to talk about a few variations of chunking or retrieval strategy, because as I said, how you do your chunking is how you query your data. This is the naive RAG. So if you pick up any of the chunking mechanism, chunk your data into a vector database, now you query, pick up the top k, top x, top n, and then ask the LLM to reason it. But there is another variant to it called hierarchical index retrieval. What you do is you create two indexes, one with the summary of your documents, another is the normal vector database. So for example, if your documents have several chapters, so let's say every chapter you summarize and create an index for. Why is this important? Because when you do a search, if you do a search on the summary index, it will be much faster than doing search on a other index, because it will have more rows. So vector databases are nothing but a normal database, so number of amounts of rows that you are taken into account in your query will also have an impact on your performance. So when you search on the summary, you get the top k summaries, and just send the leaf nodes of those summaries as a result for the context of LLM. Sentence window retrieval. This one I like quite because it's the easiest way to implement. So you chunk your data, you put it in a vector database, but once you have the results, along with the results, you actually expand your context a bit. So you pick up top X sentences or X tokens above and X tokens below, so that LLM has a bigger window to reason on. Why is it important? When a document is more or less like a tutorial, like this example of AKS, Azure Kubernetes Service, you can chunk the data, but these tutorials will have information up and below, which will help you to reason properly. So in this example, there are a few pre-configured things comes with AKS Automatic, but if you miss the top and the bottom part, the reasoning will be very, low quality, to be honest. The other one is parent-child chunks. So when you chunk your data, you also keep the parent information, so going back to the chapter and the documents. So let's say you are chunking all your data, but you're referring to a chapter always in your vector database. So when you retrieve, you first check, do I have n amounts of child leaf from a chapter? And if you do have, you send the whole chapter rather than only the chunks. And this will give you better reasoning on the chapter level rather than all the different information that you retrieve on. The last one, I think, is the fusion retrieval. So there are two different index. One is a vector index using any embedding model. Another one is an n-gram sparse index using NLP models. And you combine that, both the results at the end, using another LLM, you do a re-ranking. You say, this is my top because this is a better performing or a better to my query, and then send that as a context to the LLM. But is there only LLM which can help you to do chunking? No. I'm not sure whether you've heard about Gina AI. They are one of the biggest embedding model provider in the market, better than AWS, Azure, GCP, and any big hyperscalers. And the CEO of that company wrote a regex to chunk the data. This is very fast. I don't know how performant, how good that is, but he wrote around 100 lines of regex to chunk your data. So you don't need to ask an LLM or use a library to chunk your data, but you can use a regex as well. They also pioneered a term called late chunking. I'm going to try to explain that in simple words, but it's very difficult if you have never worked with embeddings. So let's say there's a 3-sentence talks about Berlin, and you chunk the data on those red parts. And now if you ask about Berlin or you query about Berlin, most likely you will get the first sentence where the Berlin is mentioned. But you'll miss the second two because Berlin was never mentioned on those sentences. But they are connected. So if you're asking about Berlin, maybe you also need the other two information. So what Gina AI said, before we do the chunking, we'll do the embedding first and figure out which all embeddings are connected to each other, and then combine that and make a chunking available. So you don't have to do that on your manually. They provide a library to do that. But it is a little bit different than the traditional chunking, which is this part, the left-hand side of the screen, where you do a chunk, then you embed, then you store. Here you embed first, figure out the relationship, and then store the chunking. So those were the few different patterns of chunking. There are many more. So I picked up a few which are kind of a variance and give you an idea of how different things are available in the market. And this is basically a very fast-moving technology space. So maybe when I'm talking right now, Gina AI came up with another chunking mechanism. So I have no idea. Following a recipe, I believe, as I said, as a software engineer, I like to automate things. And in a RAG, you really have to. And whenever you are thinking of building a RAG system, the first thing you should think about, how can I automate my ingestion pipeline? As I mentioned at the beginning, if you do the top part right, the rest will follow better. So normally, you will have a document store or a knowledge base or a structured data source, which will publish some events about update, delete, inserts. You will load those documents in somehow in an application, create some embeddings if you're storing in a vector database, and then add the data along with some metadata. Mind that word metadata. I'm going to come in a bit why that's important. And then you actually upsert those embedding along with those metadata into some sort of a vector store or some sort of a knowledge base. It can be Quadrant, VF8, AI search, or whatever you can pick up. Anton, I love this guy. When he came into the restaurant, he has a face like this. Actually, he always had a face like this in the whole movie. But at one point of time, he had a face like this. And this is what you want to achieve with your RAG pipeline. You want to have a feeling that anytime I change something in my document store, anytime I change something in the way I do embedding, I should be confident enough that this will not break anything. Same as any software testing, we need evaluations. Evaluations has different parameters. So you have a question or a task for which you queried a knowledge base to get some context. You use that context to generate an answer. But that question also has a ground truth. So you know if I look for this question in my document, I will get this as an answer from my knowledge store. So what you can evaluate here, you can first evaluate what is my retrieval score. Have I retrieved everything for the question I asked? Did I miss anything? Are there noises? Are there extra information that I'm retrieving which are not required? You can check the groundedness of an answer in context of a context. So if I have this information and I generated this answer, is this matching what I retrieve as my query results to the answer? You can check the relevance from the question to answer without thinking about the context. So I asked this question or I gave this task. I got this as an answer or a result back. Is that matching at all? What you can also check the similarity score. So if I have an answer and a ground truth, how similar they are. How generated answer is not hallucinating. And you can also check the accuracy. So it depends on, so there are a few platforms available which does that for you. So Llama Index has one, LangChain has one. In Azure, you also has one. But these are the 5 different parameters that you can test in your RAG pipeline. And I strongly suggest if you are thinking of building something like this, you need to think about this one first. So basically what it does is, it asks an LLM about how an LLM is doing. Sounds funny, but in a context of difference. So LLMs are stateless, so it doesn't know what it generated first time. So you provide a query, ground truth, answer and context. It'll rank all those parameters, all those 5 parameters between 0 and 1, and it will tell you how it is performing. So you can write a test that I want to be always above 80%, so 0.8 or 0.7. And then your pipeline would look like much more complete. So all those 5 steps are very much same, but at the end, you run your evaluations. So yeah, you want to get a face like this when you're building your RAG pipeline, and any change should not bring any kind of a frown face to Anton at all. But what about mastering your masterpiece? So COVID added an extra hobby in my hobby list is cooking, because I was always at home, and I needed a way to transition myself from work to life. And I started cooking. Everybody in the house is quite happy because I'm cooking. Nobody has to do anything else. I used to do the shopping, I used to do the cooking, everything. But I'm not a cook. I used to call my mother. I remember when I started living out of my home, how to cook rice. I mean, that's the easiest thing you can do in your life, to be honest. But as soon as I started cooking, I followed recipes. But over the days, I realized maybe I can add a little bit of less garlic, maybe a little bit of less ginger, maybe a little bit of more salt, maybe a pepper. Should I marinate it for a while? So I'm not saying I mastered all the recipes that I cooked, but this is how you master your skills. You add, you iterate, and you find out what are the extra things you can add. And I was talking about metadata. That's where it comes in. Because just like any database query, adding more where clause will make your query faster and make your query performant. So if you add metadata, like which page, which title, which RBAC qualities this document has, you might be able to query better data and have a better score on your evaluation pipeline. So you add, if you are having a user information, you can add the role information while embedding and query on top of that as well. The last 2 sections of my presentation is on advanced RAG. So I'm going to talk about 3 advanced RAG patterns. The first one is query transformation. It is very simple to understand, but it is equally difficult to implement because you never know how you create those queries. So in essence, what it does is it gets a task or a question, and it generates some sub-questions or sub-tasks, and it performs those sub-questions and sub-tasks in parallel. At the end, it figures out, or try to figure out, which all results I should include in my context and give it back. A simple example is, if you're asking which city has more elementary school, maybe it will be divided into 2 queries, and then at the end, you can compare and give you an answer back. So you're making the reasoning part of LLM as low as possible, because one thing is not yet LLMs are good at is good reasoning, unless you provide a better context. So you need to do a lot of prompt engineering to have that context better. But if you are starting with prompt engineering, making your RAG applications a little bit less complicated, query transformation is the way to go. The reason I say it is difficult because you do not know at the very beginning how many subqueries you want to generate and how you want to generate the subqueries. And that also takes some time to figure that out. That's why it's an advanced pattern, because you really need to know what your application is trying to do before you can apply this. The second one, which is basically talk of the town in GenAI, is agent framework. What is an agent framework? My opinion, nobody has figured out what is an agent framework yet. If you look for and ask 5 different people who are working with agentic system, they will give you 5 different answers for sure. But I'll try to give you a basic understanding which you can apply as principles when you think of an agenting system. So agenting system is basically gathering multiple inputs and creating one single set of outputs. So for example, self-driving car. It has road conditions, it has who is crossing, it has video, audio, imagery input, and the specific output it is Creating is how to drive the car, or what to take as a decision in the next nanosecond. Should I brake? Should I stop? Should I accelerate? Et cetera, et cetera, et cetera. And there are agentic systems, if you can think of, normally a RAG or any LLM system, basically you give a task and you get an output back. But in an agentic system, you should iterate multiple times before you figure out what is the best answer possible. Nuances, you don't know how many times you should iterate. Nuances, you don't know what is the better answer. So yeah, there are a lot of things that you need to consider when you're considering an agenting system. But as I said, I think, or rather we think in Microsoft, there are 5 principles you should think about when you're creating an agentic system. 1, it should have an LLM, obviously. Second, it should have a planner. So planner is something like a list of stuff which an LLM can perform. It should have a memory. It can hold data, it can think, because LLMs are stateless. It should have tools and skills to perform something, like a business operation, addition, multiplication, calling a database, or performing a business rule. It should have a state also, and it should be able to communicate with other agents. So think of a self-driving car. It should tell the other self-driving car that there is an accident on this road. Don't take this road for your next journey. So once you have these 5 principles in mind, you can think of an agentic system implementation. And to tell you, the naive implementation of agentic system is Assistance API. Have you guys heard about Assistance API from OpenAI? No one. OK. So Assistant API is on top of the OpenAI API, the OpenAPI GPT models. So what you can do is you can optionally add documents or information and add functions like multiplication, database query, or any other business logic, and give it a task, and it will automatically figure out what to do for a given query or a task. So that's the most naive implementation of agent system, but agent system can go very complex depending on what you want to achieve, to be honest. And this is one of such complex architecture diagram which we presented on last Microsoft build. And if you see, there are different components available to manage your session, to do your storage, to do your caching, do your orchestration, do your telemetry. So there is no one silver bullet to implement agent system, although there are quite a lot of agenting framework available on the market right now. To be very honest, none of them comply to those 5 principles yet. So you need to make sure that you think of those 5 principles and pick and choose what you want to do with your agentic system behaviors. The last advanced RAG pattern is graph RAG. The agent was on the operation side. The graph RAG is on the ingestion side. So how you ingest data to your knowledge base. And what this does is, this is an open source library which reason on a large set of data to figure out what are the connections between different data. So more or less, the idea is similar to late chunking, but this does on a larger set of data to figure out the connections and create a knowledge base which is connected. So for example, think of a system where you are creating a knowledge base of everyday newspapers. And a person was arrested on Sunday, but on the next week, Sunday, he was released because they couldn't prove that he was guilty. If you search for, with a naive RAG, if you search for this person's name and his criminal records, you might get the first newspaper article where he was arrested, but you will never get the second one where he was acquitted or released. In that sense of a scenario where your knowledge base are connected with each other on a larger space, graph RAG is something which can help you. But there are also nuances because it requires a lot of insights. It requires a lot of corpus of data, so it will be noisy a bit. And there is no way to figure out whether it's doing good on your data or bad other than you run evaluations on top of it. The last part of my presentation, I think I'm still good on time. Yeah, right? Is what should you cook tonight? So I told you from the very basic implementation of RAG to different patterns of chunking, different patterns of retrieval, to how you build a pipeline, automate it, evaluate it, and a few advanced RAG patterns. But when it comes to applications, you need to know where you can use them. These are some of the examples, not everything, but these are some of the examples which I personally work with some of the startups and scale-ups in Netherlands. And one of them I like is the feedback analysis. So what they do is their whole platform is to collect feedbacks from different sources. So social sources, direct sources, call centers, et cetera, and what they try to do is create intelligent reports on top of it at end of X days, of X months, or X weeks. And they try to do it with a naive RAG. We implemented it in a month or so. We failed because the results were not generating properly. So we had to use some sort of a connection between different datas. And end of the day, we used the graph RAG to implement the embedding or the knowledge base. And now the intelligent reports can take into account data from past, data from today, and try to reason between them and give a better answer back. So another one I quite like is the fraud detection. So this ISV creates software that detects frauds on real-time transactions. What they try to do is find out patterns. And finding patterns is easier because you can apply pattern matching on top of your transactions. But there are also things like images, which can be fake. There can also be interactions which points to some sort of a fraud. So for example, if there is a natural disaster happened, and normally in US, contractors come to your house to fix them, and that is some sort of a fraud. You should not be approached by a contractor. I don't know, they told me. And you can only find this answer back if you have read the report properly and try to reason on top of it. So you as a human can do that, but there is no rule engine which can reason on top of that data. So there, you need some sort of a RAG system to figure it out how things are moving in that transactional space. Where can you learn more? I have shared this also in, the slides are shared without the Disney images because I would get into trouble. But I'll share the QR code where you can find the slides. So then you can also try to read up a bit more about what RAG is, what are the advanced patterns are. And it's an ever-evolving space, so keep your eyes open. So today, things that I talked about might change tomorrow. But the basic principles I want to give you, which are pretty much the same. With that, I want to ask one last question to you guys. All of you that didn't raise the hand about, I don't know anything about RAG, how many of you go back and explain the basic RAG to your colleagues? Okay. Thank you. You can find me. I am here for the next 3 days, also the workshop days. So if you have questions, come find me. I'll be happy to chat, to be honest. And the slides are in there. Thank you.
Thank you, Soham. Please do not leave yet. We have some time for questions.
Yeah, sure.
I will need some silence so the question can be heard. There is one specific question that is repeated in different ways.
Yeah?
And it is about how do you test a retrieval score? How do you test a RAG?
Good question. I can show you.
Finally, some code.
So as I said, there is no library in Java to do it, so I wrote my own kind of a way to test it. And this test basically does a relevance and accuracy check. And what does that mean? It checks for accuracy. Given the two texts, rank these two texts between 0 to 1, 0 being not at all similar, 1 being similar, and I pass on two texts. This is written in a framework called Semantic Kernel. They have a Java library, so as I said, I'm a Java guy, so I use that. And also from Microsoft and open source, so why not? And the second one I check is the relevancy. So there I say, given the question, similar, rank between 0 and 1, given the question and an answer, can you please rank it? And in a test, which you can actually use that as a, an array input of questions and ground truth. So what I did was here, what is the cancellation policy, and provided the ground truth from my policy document. So this policy document is basically a single document with all the policies there. And what it is testing, by the way, so, oh, wow. Where is my, oh, here. It's still running. So this is a very naive application which interacts with a structured database with all the bookings and also has a knowledge base of the policies. If it works with my mobile internet, yeah. So it gives me an answer like this. So this is an answer which I expect from my application. And if you look back to my policy document, these are the last 3 lines are my ground truth. So that's what I provided in my test. I said, that's my question, that's my ground truth, and now calculate the relevance and accuracy to it. As I said, there are frameworks which will help you to do that, but this is how you really write your evaluations. So this is a test. So I'm a Spring Boot lover. So I did a Spring Boot test here, so you can run the Spring Boot test whenever you're running this application or changing this application, basically. Does that answer the question a bit? This is also in my GitHub. My GitHub is a graveyard of unfinished, worthless projects, but you can find this as well there. Don't look at my coding style, but I try to understand the idea. But you can connect me if you want, if you have more questions.
So all the information will be shared with you guys after the conference, so don't feel like you're going to miss out of something, right? So the next question, as we have time, can you use multiple frameworks on the same data to perform the same question and use those responses combined to build a more accurate answer?
Yes, if you remember, I showed a hybrid or a reciprocal search. I showed you a vector and an n-gram sparse index, but you can choose to have another vectorization method or another embedding model or another chunking mechanism and then do a reciprocal. But I would say figure out what chunking and what overlap you really do need on a subset of a data. So pick up, I don't know, 5 megabytes or 20 chapters of your document or a few rows from your database table. Run your evaluations first, write your tests, so test-driven development. So run your evaluations, pick up a chunking mechanism which is easier for you to understand or implement. See how you're getting it, how your relevance, accuracy, context score is, and decide from there. There is plenty of options to choose from, but as good as your evaluations are, will be as good as your choices will be. Yeah?
Okay, and the last question, and it has to do with secrets.
Okay.
How to keep the company secrets safe? Example, flight booking change. You have a company algorithm that selects the best, cheapest flight on flight change. How to integrate the document algorithm without it getting public?
Oh yeah, it'll not be public, to be honest. Your backend is backend. This is Okay, will I explain this in a better way? So you have a service or a module or some sort of algorithm which does this for you, and you are using the output of it to perform the task. So your algorithm is never public, to be honest. So this is how microservice or any sort of architecture works. So you have a different module to does your algorithmic operations. You use the output to reason on top of it. So it will not be public for anybody, to be honest. And the airline example is something you can think of, like depending on who the user is or what the ticket is, you give that person a special sort of a care. So if it's a business class, maybe you don't really apply cancellation charges. So you can apply those in your backend properly. So you don't need to do the query on that, but you can manage on top of your user profile what actions you want to perform. So it is not only querying and giving the context to LLM, you can also introduce a small service or a module which does really implement that algorithm for you, to be honest. If you are confused, come back to me later. We can draw some diagrams and make it clear for you, or try to make it clear for you. Yeah?
Thank you, Soham.
Thanks a lot.